Hi, it's Miss Miles. Today we're going to talk about rate of change and slope. Learning target number 1. You'll identify the rate of change from a table, graph, equation, and context. You will also communicate about math and model with mathematics today. Here's your activator problem. Adam leaves his house and jogs to Corey's house. Later they walk to a local pizza shop. The graph below shows the distance Adam traveled between the time he left home and when he arrived at the pizza shop. So let's answer 3 questions about this graph. When was Adam traveling the fastest? Can you tell from looking at the graph that from 0 to 7 minutes he traveled the fastest? How long was Adam at Corey's house? He was there between the times of 7 minutes and 15 minutes, so he was there for 8 minutes. And I can tell because the graph was flat then, so he was not moving any farther away from his own house. And let's compare the graph during the times that Adam was jogging to Corey's and when they were walking to the pizza shop. The rate of change was faster when he was jogging, right? Because the graph has a steeper slope then. So when the slope is steepest, the rate of change is fastest. In this graph, we want to determine the rate of change of the car traveling at constant speed. Well, it looks like in 1 hour, the car has driven 60 miles. And so when it comes to miles and hours, rate of change is another way of saying speed. And so 60 miles per hour is the rate of change of this car. Now on this table, which shows fees for renting kayaks, we're asked to determine the rate of change for the rental fees. So here's what I notice in the table. As the hours increase by 2, the cost increases by $28. Do you see that? So the rate of change is $28 for every 2 hours, but we can simplify that to $14 per hour. Now there's something important that you need to notice. If you rented a kayak for 2 hours, even though it should cost $28, you're paying $32.50. So that means that there was an initial rental fee of $4.50. So very often you're going to be looking for that initial amount, and you'll find it in a table like we have seen here or in a graph. All right, slope of a line is the measure of its steepness. It's also the constant rate of change of that line or linear function. If you find any 2 points that lie on the line, you can measure the slope by finding the rise and the run and writing that ratio, rise over run. So in this case, the slope is a rise of 4 and a run of 2. And 4 divided by 2 is 2. This line has a slope of positive 2. Now the slopes of these lines. The line on the left has a positive slope. The rise is 2 and the run is 4. And 2 over 4 is another name for the fraction 1/2. We leave slope in terms of fractions. We prefer fractions over decimals with slope. Now in the graph on the right, the rise is a -9 and the run is positive 3. So the slope is -3. Okay, let's look at special case lines. Any horizontal line will always have a slope of 0. The slope of any vertical line will always be undefined. Sometimes you'll see certain books call it no slope. That means it cannot be measured. it's meaningless to determine the slope of a vertical line because you cannot divide by 0. And that's why the slope of a vertical line is undefined, because when you do rise over the run is 0. Okay, let's look at the rule of 4. This is a recipe for salsa. And it says for every 4 servings of salsa, 10 ounces of black beans are required. So let's try to make sense with a table. So here we have our table. And the important thing to notice about this table is that you could say for every 2 servings there's 5 ounces of black beans. So therefore for every 1 serving it's 5 halves ounces. So when you go to make your graph, you can plot those points, and this is actually a direct variation, isn't it? Because it's a straight line that goes right through the origin. And the equation of this line is y equals 5 halves x. So this particular line has a positive slope. As the number of servings of salsa increases, so does the ounces of black beans that you will need. Okay, so I'm going to read the context, but then please put the video on pause, use a whiteboard, and figure out the rule of 4 with your group, okay? Meg opened a savings account with $40. Every month she deposited $15. Can you please represent that using a table, a graph, and an equation? Please put the video on pause now. Okay, so now we're going to complete and check to see how you did with your rule of 4. The table would look like this. She started off with $40, but she put $15 a month into her account. The graph, if you put months or the time on the horizontal axis, and what I decided to do was to count by tens on the y-axis. That'll be her balance in her account. And here is her first point, right? She deposited $40 when she opened the account, and then $15 every month after that. And then connect those dots. That's your linear equation. Now the equation of this line, it's going to be y equals, remember, she starts with 40. So 40 plus 15 times x. I hope that makes sense to you. All right, so let's double check that you're meeting the learning target. Can you identify the rate of change from a table, graph, equation, and context? And have you been communicating about and modeling with mathematics? In other words, are you comfortable going from graph to table to equation to context? All right, so now we're going to pass out a cute little riddle sheet. What might you have if you don't feel well? And the directions are there. The teacher will go over this with you. And if your riddle makes sense, probably will be corny, but if it makes sense, you have been able to figure out the slope of these 8 lines. So put the video on pause, work this out, and then press play again once you're ready to check. Okay, so hopefully this particular riddle sheet went fine for you. And let's summarize what we've learned about slope today and rate of change. Remember, rise over run, that's the important thing. So a positive slope, it looks like little ski bird is going uphill. As x increases, y increases. Now with the negative slope, as x increases, what happens to y, right? That's decreasing. And with a 0 slope, remember, it's a horizontal line. And with a vertical line, the slope is undefined. Okay, now we have just a few problems for you to do as an exit ticket. So what I'm going to ask you to do is write down these problems on graph paper and put this video on pause, and this will be your ticket to leave. Okay, hopefully you feel confident about what you did today. Thank you.